This is Unit 2, Segments, Lines, and Angles. Preview Video 2.5, Angle, Properties, and Pairs. Sit tall. Ready? Take a deep breath. Deep breath, hold. Birthday candle. Close your eyes and just take a couple seconds and thank God for this moment. Couple things you're going to need here, friends, as you are turning to your preview notes. You should probably have some colors handy. Colors are going to be really helpful, colors of some sort. Okay. And you are going to need your protractors, probably some scissors. We're doing angle, properties, and pairs. Angle, properties. An angle is sorry about that, friends. Let's take a look at what an angle is. An angle is simply two rays joined at a common point called a vertex. So if I have one ray and then another ray and they have a common endpoint, that is called a vertex, and this is an angle. Now, when we draw an angle, right here, we're going to draw an angle XYZ with vertex Y. We're going to give it a measure of 65 degrees. So taking a look here, we're going to measure 65 degrees, and it doesn't matter which way you go, so either I can go this way at 65, which I'm going to do, and I'm going to make that point X, and then this is Y, and then I'm going to go over here and make this Z, so that our angle here, X, Y, Z, is 65 degrees. Now, there's two different notations you need to be familiar with angles. If I want to talk about the physical angle itself, I use three letters, X, Y, Z. And that's how we make note of a thing. The angle, going this way, ZYX, is the exact angle. I could also add a number here if I wanted to and name it just by a number. So if I want to put a number 1 there, I could call this simply angle 1. You usually put it right in the mouth. Now, if I want to talk about the measure of the angle, the degree measure of XYZ, that's what this little m is for. That little m means measure of. So if I want to talk about the measure of XYZ, it would equal 65 degrees. M equals measure. We're going to be using protractors in class, so make sure you bring that with you next class. Ready? Turn the page. So we're going to do a little bit of drawing here. It says draw an angle EFG with an interior ray FV and an interior point U and an exterior point W. So an angle EFG. It doesn't tell you whether it's acute or obtuse, so it doesn't matter. What does matter is F is the middle point, so F must be the vertex. And which one's E and which one's G doesn't matter. So I can do EFG this way or EFG that way. Interior ray. Interior means a ray somewhere in the middle, but it didn't say it's in exactly the middle. Exactly in the middle is a bisector, and that's the next lesson. So notice F is the vertex, so somewhere inside I have FV, the ray. Interior point, U. So somewhere here I have a random point inside the angle, and then I have an exterior point outside of the angle, W. So that just helps define the difference between interior and exterior. I want you to try to draw this on your own. Pause the video, draw, and then restart. Okay, get your red pen out. Let's check your work. We have CAT, an angle. It doesn't say whether it's acute or obtuse. What is important here is that A is your vertex. And then C and T, that could be switched. Interior ray, AD. So somewhere inside AD. Trace and sweep, CAD. Then draw an interior ray and CAD, label it AE. So inside here, you have another interior ray starting with A, which is the vertex, and then E. So it's okay if this is totally flipped the other direction. What's important is you have this angle swept and AE is somewhere in that swept angle. Types of angles. If an angle equals 90 degrees, we call that a right angle. And if it is a right angle, you must have the right angle box there. If I ask you to draw a right angle and you do not have a box there, it is not a right angle. If you have an angle less than 90, it's acute. If you have an angle more than 90, it's obtuse. If you have an angle, technically two rays with a common endpoint, and it makes 180 degrees, we call that a straight angle, which is a line. It's just a fancy way of saying a line. Let's do this one together, one step at a time. It says, draw an acute angle RST with an interior ray SO. So it's acute, so it's not 90. It doesn't matter whether R is down here or up here. What does matter is S is the vertex, so your S must be the hinge. And it has an interior ray, SO, so somewhere in here is SO. Now, watch carefully. RSO is 3 times as large as OST. Let me color code this. R, S, O, blue, is 3 times as large as O, S, T. That means this is 3x and x. Trace and sweep RST. RST sweep. And we're told that is 76 degrees. Find everything possible. Well, what we know is true is our thing equation is simply going to be this angle plus this angle equals the large angle. Blue plus green equals orange, or whatever colors you used. Now, there's your thing equation. Let's go ahead and circle, plug, chug. Solve. And then let's see if it worked. So if I go here, that's 19. And then over here, I'm going to go 3 times 19. $57, and here's your check. 57 and 19. 76, you got it. Next page. This page you're going to do on your own. So, working in pencil and then correct in red pen. Pause the video. Welcome back. Let's see how you did here. So it says draw a right angle DOG. This was the most important step. With an interior ray OT. And then here's our algebra. DOT is going to be 4x plus 5. TOG is 4x plus 13. And then this whole thing is 90. Find everything possible. So your thing equation is angle plus angle equals the big angle. So here's your thing equation. We have 4x plus 5, right there, plus 4x plus 13 equals 90 degrees. Solve. Now, once you have that, you want to plug it in and see if it actually works. 4 times 9 is 36 plus 5. That's going to be 41. 4 times 9 is 36 plus 13. It's going to be 49 in the margin. 41, 49. There you go. There's your check. So just like we learned that segments add to get bigger segments. Angles can add to get bigger angles. Now, this is very important. We're going to do a lot of new vocabulary here. And our vocabulary are these 5 words. I'm going to write them, and then we're going to go over them. These 5 vocabulary words are very, very important for the rest of the year. So this isn't something you can forget. Let's write the vocabulary words right up here. Okay, this word is adjacent, linear pair, vertical angles, supplementary, complementary. These 5 vocabulary words are very, very critical for this particular lesson. Let's go over what they mean. Two angles that share a spine. They're back to back. They share a spine. Those are called adjacent. Let me give you an example. So for example, ACP and PCZ, those are adjacent. Angle ACP and angle PCZ. Now, if you look very carefully, they're adjacent. Here's a clue in the letters themselves. Do you notice how we have 2 overlapping letters? That is what we call the spine, or a common ray. So adjacent means next to, share a spine. Linear pair are also adjacent. Two angles, if you go like this, they share a spine, meaning back to back, and put your elbow straight out, they make a line. Share a spine, make a line. That would be any 2 angles that are both adjacent and they make a line. So that would be like this. Angle RCF would be 1, and FCZ would be another. They share a spine and they make a line. So share a spine, they share a spine, but they make a straight line, which means they're always going to add up to 180. So these 2 angles are a linear pair. Angle RCF and angle FCZ. They share a spine and make a line. Notice the repetition of the letters again. That's the adjacent part. That's a linear pair. Linear, line, pair, 2. Of these 5 vocabulary words, this is by far the most critical. Most critical meaning where you're going to see them the most and the most useful. Vertical angles are 2 opposite angles created by 2 straight lines. So in this diagram, trace 2 straight lines. Just trace 2 of them. Those 2 straight lines, FP and RZ. The 2 angles that are directly across from each other, this angle the blue angle and the green angle, they're directly across from each other. Those are called vertical angles. So anytime you have two straight lines, the angles directly across from each other are vertical. Very important, they're also going to be congruent. Vertical angles are always congruent. Complementary angles. Complementary angles, make a C with your hand. Complementary adds up to 90 degrees. Do it again. Complementary adds up to 90 degrees. So any two angles that add up to 90 degrees would be considered complementary. So this angle right here, angle ACR, and angle RCF, ACR, RCF, they are complementary. Complementary adds up to 90 degrees. Supplementary is any two angles that add up to 180. So any two angles that add up to 180. You're like, wait a minute, didn't I see that before? And you did, right here in a linear pair. So what's really important is that all linear pairs share a spine, make a line, are automatically supplementary. But I could have two angles. Let's say this angle is 50 and this angle here is 130, and they're not adjacent, but I would say that they do add up to 180. So I would call those supplementary, but not a linear pair. So all linear pairs automatically supplementary, but not all angles are supplementary are linear pairs. Okay, you're going to zoom through here. In the following diagrams, sweep the given angles A and B. Determine if they're one of these 5 vocabulary words: adjacent, linear pair, supplementary, complementary, vertical, or a combination. Let me give you an example. Trace, trace, sweep, sweep. In this case, A and B are vertical angles, and they would automatically be congruent. Let's take a look here. I see 90. So this angle and this angle add up to 90. That means these two angles are complementary, but since they also share a spine, they're also adjacent. So these angles are adjacent and complementary. This page you're going to do on your own. Zoom through, mark it with the same vocabulary words, and then restart the video. Pause. Okay, welcome back. Let's see how you did here. These two angles, these are a linear pair, and they're also supplementary. These two angles are only adjacent. That's it. They don't share a spine, make a line. These angles are adjacent. They are also a linear pair. And they are also supplementary because of the 180. These angles made by two straight lines are vertical. These two angles, they are adjacent. They are also a linear pair. They also add up to 180, so they are supplementary. These two angles are adjacent and complementary. Check how you did. This last page, let's do this one together. Now we're going to show how to use these properties to solve for unknowns. So right here, we're going to make a thing equation. That's very important. And then find all possible angles. So we go like this. Boom. And what we have here is we know that that blue angle and the green angle must equal 180. Why? Because they are a linear pair. Now circle, plug, chug. So we find that x equals 71. So let's see what is true. 2 times 71 is 142 plus 1. That makes this 143. Now, I don't tell you just to find x. I tell you to find everything. So what we have here is vertical angles. So if this is 37, over here, this is 37. We also have vertical angles going this way. So if that's 143, this is also 143. Coming down here, what's true here? I have two straight lines, which means in this case, my blue angle and my green angle are of equal measure. So you solve, excuse me, that's not plus, that's minus. Five times 15 is 75, plus 1 is 76, of course. And then I could go like this, and 180 minus 76 would give 104, and then this is also 104. What you want to do here, students, is take the time to summarize what you have learned in this lesson.